All right. Well, it looks like Victoria's all set. Let's get started. Hi, everybody. My name is Dan Garcia. I'm a teaching professor at UC Berkeley. I'm delighted. Oops, I should stop. Let me know when to go. Sorry about that. All right. Thank you, Lauren, for the go ahead. All right, folks, welcome everybody to this hour-long talk at SnapCon 2023. My name is Dan Garcia. I'm a teaching professor at UC Berkeley. He, him pronouns. So delighted to be here to talk about the joys and challenges of auto-grading in Snap and BJC with note late penalties. I'm joined on the stage by our wonderful group of TAs who have been, I'm having a little bit of music in the background. I'll turn that off. My TAs and former TAs, Lam, Victoria, and Vedansh, and they'll all have a part of this presentation. So let's jump right in. We've got about an hour and a lot of material to cover. All right, so here's the overview. Learning, as it usually happens in classrooms all around the world, students come in with different amounts, different levels of aptitude, certainly, and different levels of preparation. And for non-majors classes like this one, we get freshmen and sophomores and folks who come in with lots of different, a big variance in the amount of preparation they have for early computer science. Most haven't done anything, and some have holes in their math background based on their poor high schools. And so at the end of the day, they get A through F grades. So the mantra we all must be happy with, because no, I don't see anybody protesting this, is that we have a fixed time. You have 1 semester of work, 1 term, and variable learning. And so people come in with a bell curve and they have a bell curve of achievement. And this is clearly a huge problem for equity goals. If we actually looked deeper into the numbers of that, it wouldn't look very equitable. So the big idea that was proposed 55 years ago by Benjamin Bloom was that students must achieve a level of mastery, for example, 90% on a quiz, on earlier material before they can move on to later material. The mantra here is fixed learning, variable time. It may take you longer to get there, but there's a bar. And by the way, this is something that people have, we didn't invent this. Benjamin Bloom suggested this. It's been done in K-12, in primary and secondary school before you get to higher ed for years and years and years. My son used to come home from school and he would say, here's my essay, and have red marks all over it where the teacher had corrected it and said, rewrite this for full credit. So this is something that people have been doing forever. We're not the first to think of it, but it isn't done for the most part in higher education because we have hundreds and hundreds of students in many of our situations. And how do you do that? So as I mentioned, and this has been done, you know, if you go to take a driving test, you don't get to get your driving test until you reach a bar. And it might take you many times to pass your driving test. So this is a common thing, this way of having a bar that says there's a fixed bar, and we need to let you have as much time as it takes before you pass over the bar. You might imagine a very patient teacher. This could be a private tutor or a golf tutor or a piano tutor or someone working one-on-one tennis tutor with students, maybe a math tutor, where you're not allowed to move on to the next topic, and I'm going to be very patient with you and continue to make exercise after exercise and just work with you and know exactly what you need and work with you. That's wonderful. Doesn't work at scale. The big idea at scale is we need some system. We need some automated system. Thank you, AI. But there's not that much AI in the first version of this, but there hopefully will be some in the later versions, in which you have a dynamic randomized problem generator, the same thing that patient teacher was doing, to one after the other to give you new problems to do this. You've got 4 different students, maybe many different students, and each of them getting a different problem, being at a different place in the course. Now the course is being very self-paced, and you're letting them work with their own pace until they achieve that mastery to be able to move to the next topic. So how to do this at scale? We weren't doing this at scale for the most part because we didn't have technology. Now we do. There's a wonderful system we happened upon called Prairie Learn. It was invented at the University of Illinois here in the US. It's free, it's open source, and other universities are also using it. And the key idea here is you program into the system rather than writing questions. Every exam before I did this was I would go into a Word document or a Google Doc and write a PDF, a single question for every topic, and then we would print the PDF and give the exam in the evening. That's how we did this. But the idea is you're switching that model from rather than writing questions to writing question generators. What is a question generator? It's a piece of software. Basically, it's just an HTML page. And anything you can display in HTML, you can generate and then have different versions. So here are 4 different examples. I say the word rich here. This means rich in a way of really not just multiple choice we're talking about, but really nicely engaged exercises that allow you to explore that material in almost any way you'd like. On the left, the student is being asked to draw a piecewise quadratic curve by clicking these curve points and actually drawing it. The second one is students are asked to calculate the centroid of these objects. The third picture is a picture of a Boolean circuit, and you're asked to do the simplification using Boolean algebra and then come up with the simplified Boolean expression. I use this problem in my class in computer architecture. And finally, this is the data path for a CPU, and you are literally touching lines on the data path and saying where those lines, what the values are. Are they 0? Is there no current? Is there a 0, logical 1, or do I not care because it doesn't actually matter in the computation? So these can be used for homework, for practice, for project, or for exams, for all of these. And we've exploited almost all of these for BJC, and we're super excited about using this. In fact, here's an example from my BJC course. This is, we teach students how to do a fractal. And these are 3 different versions. As I said, there's a web page, and I have some Python. The way Prairie Learn works is there's some Python code that runs in the background and then feeds the web page. Well, that Python code can have a random number generator. So that random number generator can determine whether the fractal, in this case, draws in this pattern or this pattern. So this is the code I had is the same structure, and I'm asking myself, notice that the first n equals 0, n equals 1, I guess, is a straight line. N equals 2 is the same shape. Notice these are the same shape. It's just that which line in bold recurses and which line doesn't. If it's a straight line without a bold line, it just is a straight line. If it's notice that this never changes. See, it never changes in all the versions of it. Anything that's bold recurses. So that's what you call the recursive rather than drawing a line. So every kid is basically solving the same problem, but it's whether you call draw line or whether you call the recursive call to draw line. So this is it. So 3 different kids are getting 3 different versions. So this is great. I allow the exams to be take home now. I never did that before, but I can trust that each kid is a different version. And now I actually have a whole team working on anti-cheating, and we've discovered almost none of it. In fact, just as much as we ever did back in the days of paper and pencil exams. So I love giving kids 4 days to take my exams, and it really only takes 2 or 3 hours, but they can take this through 2 or 3 hours over 4 days. The students love this, to be able to work for a problem, go to sleep, think on it, come back and try the next day. It's wonderful. But the key question is, how do you auto grade this? How am I going to auto grade 250 students? I think and we actually play with a lot of things. Do we compare the picture? We're comparing pixels, using some libraries. Are we checking their code? And Victoria's going to talk about how we do some of that. So this is the first part. We're thinking about how to auto grade this. So Prairie Learn is spinning up a brand new problem. It's now take home, whole different experience. And the student has that be auto graded. We're trying to remove people out of this because I want to do the following, okay? I have happened upon this, by the way, this whole movement is called grading for equity. And so this idea of grading for equity is that to have equitable grading, you have to think about different policies. So here's the key. This new proposal is called A's for All. A's for All means that the bar for what it takes to get an A doesn't change. An A was the same as it was before when I had one exam and one attempt at doing this. The transformation in terms of policies is that the belief that every student can succeed, and every time I'm not giving an A, I'm doing something wrong. So how can I change my class? This is like a whole epiphany I hit, and I realized I was doing it wrong for 23 years. I teach an introductory course. So, a kid graduates from my course with a C, and you know what they say to themselves? Well, I guess computer science isn't for me. And every single person who gives a C and below, and maybe even a B, just depending on what the kid's standard is, just a student in a class is silently sending the message that you can't do this. A C says you can't do this. I guess you might as well choose a different major. And I was doing that. I was giving C's and D's, and I think that was wrong. I want to allow that kid, if they're willing to put in the time and effort, that's why I say here, if the kid doesn't have the time, they're a senior, go ahead, take the B or C and graduate, no problem. Handshake, you're done. If they don't have the interest, let's say they're not a CS major or don't care, I'm a biology major, I don't care, this is just for fun, I'll take the C and walk away. That's okay too. That's also okay. Basically, it says the kid can get any grade they're willing to work for. And the kids can finish the course afterwards. You can give them an incomplete and they can keep working and then finish it afterwards. So here's the mechanism. I'm going to get to how we do this in Snap. I'm really excited about this. One, we have multiple exam retakes. My Prairie Learn has the answers pre-programmed into the system. So for all the other non-programming problems, maybe I ask a question about, societal implications of technology, and that might have an essay, might some things, and so that's auto-graded. I pre-programmed some kind of auto-graded thing. We have to be able to auto-grade those fractals. The score is maxed over each question. So I had 3 midterms. I had not just three of the same midterms. So midterm and then midterm retake and midterm retake number 2. And that I say I have 5 questions and I'm going to take the max over 5 topics. And if you ace the first 4, if you use my hand, ace the first 4 topics, but bomb the thumb, well, the next exam, you already got the points for the fingers. You just take the thumb question. So the retakes are super easy and super fast the next time. And it's the max over all of those. So you already got the finger questions, right? You have that in the bank. Those are your points already. Let's try to get your thumb higher. That's all it is. You try to get your thumb higher until you try to get that hard concept you couldn't get. I also have removed all late penalties. This is a huge transformation. All late penalties are gone. If a student needs more time, you're going to be given. You have to ask for it, but you're going to be given that. And we try to auto-grade the projects if we can. We have a last project, which is students get to do anything. Well, those students who do anything, that can't be auto-graded because, one kid's making a game, one kid's making a tutorial, that can't be auto-graded. So we have our human readers, and there's also an essay. We don't have AI grading those yet, so we have real humans reading the essays and giving grades based on a rubric. But everything else that's programming, we auto-grade. So that's the key. I'm going to talk about how we do that. And students can keep working with the autograder until they're happy. That's the key. By the way, I want to show you an example of the exam. This is an example of the midterm. Remember this fractal I talked about? Here's this fractal, n equals 1, 2, 3, and 4. If I remember this picture here, this kind of lower staircase with these 3 lines, 4 lines here. Ready? I click on new variant, and now here, and maybe that was the same one. Let me click here again. And look, that's the same problem, just flipped. So every kid has a different problem, and whether you turn right or turn left, basically it's the same problem. So I'm pretty excited about how to do that on exams, but how do you auto-grade that? So if it's a project, they can work with AutoGrader until they're happy. So by the way, this is part of 4 key movements in education that I believe. We talked about Bloom's Master Learning from 55 years ago. If you haven't seen these other books, grab these books off the shelf of the library from Amazon and buy these and read these. These are powerful books, and they also changed my direction. Carol Dweck's growth mindset. You can keep working. It's not a fixed mindset. You have a growth mindset. The brain is like a muscle. You got to exercise it. So you might need more practice than other kids. That's fine. Maybe even Michael Jordan had to go to the gym. So the brain is a muscle. That's the growth mindset. I mentioned Bloom. Joe Feldman wrote a book called Grading for Equity. If you start anywhere, start on this book. This book is the book that really transformed. I attended some PD, and this transformed how I want to teach my classes from now on forever. This is it. I'm done. I'm a convert. I'm trying to preach the religion to everybody who will listen. And the 4th is Lyndon Nilsson's Specifications Grading, which talks about contract grading. It talks about something I haven't yet done, which is remove points from the equation and just have it be mastery of topics. She also talks about don't have a hidden specification. Let it be out there. Post what it takes to get an A on the wall, and let's all agree on what that is. So use a spec rather than a hidden, here's my hidden agenda that I was looking for in your essay. No, publish what that is I'm looking for in your essay, and then share that with all the students. So these 4 things, I think it's like a nexus happening. This is a very exciting time in education, and 4 things are happening all at once. So I'm going to step back for a second and say, in BJC, I've always wanted to focus on functional programming. There are 2 programming paradigms we focus on in BJC. There's a third called event-based programming where you teach them to make them do their games, but really these are the 2 that we want to teach when we teach computer science. The functional paradigm says that you're writing functions and the data is immutable. You're just passing a lot of functions around. And functions as data says higher order functions. Those who have used map, keep, and combine, it says that you can pass functions in. This is part of the, the scheme or list-based idea of the functional programming paradigm. Debugging is super easy because you're not changing state. Imperative or sequential, is the steps. These are all the commands that we've seen. So if you want to do the same thing, put 1 in front of the list of 2, 3 to get 1, 2, 3, you'd be doing this thing. Set my list, and you're setting things, and there's a lot of equal signs in programming languages here where you're assigning things. We don't do that in a purely functional paradigm. And insert 1 in terms of list, insert 1 at 1 in my list. Lots of state. Debugging's hard because you have to undo that state when you retest it. So I want to try to change CS10 to be more functional. That's the key. So here are the design goals. And I'm going to pass over to my team to talk about this. The design goals are, number 1, do not modify Snap. I've attended every SnapCon since the beginning. I've been so delighted to be part of this community. This is so exciting to be able to share what we're doing in BJC is in support of, and using it in support of Snap as well. I don't want to modify Snap. I've seen many other SnapCon presentations with Autograding in which they modified and hacked up Snap to do powerful things. I've even had folks who worked with me, Michael Ball and other folks have worked to make our versions of Snap that did things. We said, those are hard to maintain, as you all know. So can we not modify Snap? Can we actually use vanilla Snap to do this? I want to be able to give those students standardized unit tests. If I'm going to just do functional programming, let me just give unit tests to do this. Students should be able to know what their overall score is throughout the programming. We want to hide all the autograding machinery, and we got to be able to do this on autograders for 250 projects. So here's my very brief demo. Project 2 used to be try to make a word guessing program, and they had to, in the spec for it, we would ask them, can you make the app where it asks the user and does this? I took that all the way and I did that for them. I just want them to write blocks now. So this is now what we ask of them. Just fill in these blocks. Each one is either a reporter or a predicate. Obviously, predicates are special cases of reporters. This tells you what it should do. And if I scroll, you're going to see that this is the whole code that runs the program. This is playing the spelling bee game if you ever played this on New York Times. And these are the tests I'm going to use. I even tell them the tests. Later, I actually don't tell them the tests. I have hidden tests in the sense of they have to write their own tests because we don't always hand them the test. We want to have them learn how to write their own tests. But in the early projects, we hand them the tests. So these are all the tests, okay? Now, this is the working version. This is the working version that all these are now going to work. So here, this one doesn't work here. I click on letter of A. This is supposed to report whether this is a letter or not. It puts blank. It's not working. This one, is A a letter? Yes, it is, okay? So each student just fills this in. They right click and they do this. And then, by the way, we absolutely love the idea of micro worlds. So here are the blocks they'll ever need. All the blocks they'll ever need. Notice you're not seeing a single block that is a command block, except for set and script, in case you want to do a temporary variable and remember that for the other, but there's no global variable set up. So all of these are just reporter blocks. And it's really, really wonderful to think about that. Now, here's how I've done this. Here's the demo. They can try to write all this code and then to test it one by one. Test it one by one. Once you get it working, you test it one by one. Okay, test it one by one. When they're all done, they just click the autograder button. This is just a block that tests basically says, does letter A report true? Letter A is supposed to report true. And so gives them points for that. So this is it. This is something that they just click on and it reports a JSON that's going to be used by somebody else. And I say, look, when this says score of 1, you've got it working. It doesn't work. Let's see how the working solution works. Does that work? Let's click on this. I say autograder score of 1. So that's perfect. When they get a score of 1, multiply it by 100, and that's your point. Oh, you got 100 points out of that. So this is the fraction. This is a fraction of what the points they got. Now, here's a kid who didn't get it right. And in the first version, we didn't have any more than this. Just keep trying until you get that one, but they don't know what they're failing. I said, well, you're just failing these tests. I tell you what it should report. If this doesn't report false, it's not going to give you the points that add to the score. Well, they want to see that. So let me show you what they do now. I added this autograder table that reveals this. So if I click on this and this bottom of the script does not show, I might have to drag this out here because the resize guy isn't there. Here it is. I click on this, and I'm going to grab the resize here in Zoom and just show you what happens. These are the test cases. I can just move this over, and you see all the test cases here are literally just shown in this table. This is a pretty table. I love this. I love table view. This is what the expected value. This is what you're giving me. You're giving me nothing because you didn't fill anything in. This is what it's worth, and this is your score. Note if you scroll down at the end, total. One of these things passes because it's supposed to return like, empty, and so it counts as nothing. Anyway, this thing still passes, but the point is there's supposed to be 20 out of 20. It's 2 out of 20. We go over here and we do the same thing here. Let's click on this one and we click on this. And if I scroll to the bottom, notice I got 20 out of 20. So that's it. We hand this to the student. They just basically work in this world. Oh yeah, that's right. You can double click on, so you can double click on List Watcher to open it in dialog. Thank you so much. That's a useful hack. So the point is they already have the autograder built into the project. I have not touched Snap. I just basically wrote a block that runs through all these test cases and then lets them see it. So they just can either keep clicking this until they get the 1, or they can click the table to see where they're failing that. And then they work on that block. So they can figure out if they're not getting full points, what that is. They're done. Once they get I tell the students for the first time ever, I say, until you get a 1, until you get a perfect job, don't submit it. If the deadline hits and you're not done, keep working on it. I'd rather have you have mastery than, so I'm not heavy-handed, I don't force mastery, but I'd rather have you have mastery before you give me the work. That's it. I'm gonna pass over this now to my next presenters. Lam and Victoria are gonna talk about how do we build and maintain this autograder, and I'll stop sharing. Thank you so much.
All right, can you hear me? All right, hello everyone, I'm Lam. I just realized my background is flipped. I'm not sure why that is, but I hope you can bear with that. Okay, I'm gonna share my screen. Actually, Victoria, could you share? Because then, yeah.
Yeah,
and I'll tell you when to. Yeah.
Okay, perfect. Yeah. Okay.
Yeah. Okay.
Oops. Okay.
Yeah. Okay. So I worked with Dan back in 2020 and 2021 as a core staff for CS10 BJC, and in which capacity I had to grade a lot of assignments. And in the next couple slides, I'm gonna try to convince you of some of the challenges of autograding and also its merits. And hopefully we can walk through like a small example to see how like the autograder as it is now works under the hood. So back then you have to manually load in the student's project. And then for each of the students' block, you actually have to find it, because people might not organize them the same way. So you have to look through the project, dig through like all the blocks to find the student's project. And then for each block, you have to figure out how many tests you're gonna have for it, and then manually fill out the input and then click the block to execute. That's a very big part that we hope to autograde or to automate. And then afterwards, you can check the solution if it's a reporter, which usually it is. You can check the bubble to see if the solution matches what you expect. Yeah, so the problem is this does not scale. You have to open a tab for every assignment, and you have to wait for the project to load. If you're really good, you can have like 3 tabs open at once, and then like you can load into 2 other projects while you grade the one. But still, this is not very scalable. So if you could go to the next slide. So we need to figure out a way to run Snap without the visuals, because we don't really care about it when it comes to autograding. So that comes with a certain some challenges. As you know, Snap is a very visual and interactive programming language. So you have to click on blocks, drag and drop. So if you run it headless without the visuals, well, the obvious challenge is that how do you even find the blocks, right? So before version 8, you would have to understand the source code and use JavaScript. And in the JavaScript console, you can actually find and dig through like the global blocks. And that's how you would find blocks in a scripting language like JavaScript. But after version 8, there's actually built-in blocks that help you find certain blocks. So in this example, I have a function called double defined. You can get the label of that block, and in the reverse manner, you can get the block using the label, right? So that's the find first item block section. Yeah, could you go to the next slide, please? Yeah, so that's how you find an item or a block. So how do you call the block? So how do you waive away this need to manually input in the inputs, well, you can use the call block, right? So you can call certain blocks with inputs. And so a test case might look like something on the bottom. So you set a number of points, and then you can check for each case if some inputs matches the expected output. So doubling of 5 should equal to 10. And if that's the case, then the student has passed the test. So you increase the points by 1. Yeah. Can you go to the next slide? Okay. Yeah, this I was doing the examples in V9. That's why you get the the new features. Okay. Could you go back one block? Yeah. So if we put all of that together, you can make a block, much like the autograder that Dan has. So inside of it, it might look something like this, where you find the block, and this is only for one test case. You can feel free to use higher order function to write a bunch of test case in a table like Dan does. And then for each entry, which is basically an input, expected output, and point value tuple, you can extract each element out. And in this case, you might have an input as the first item, the output as the second item, and the point value as the third item of one entry in like a list of lists. And then you can choose item 1 of that to be where the 5 is. You can choose the other item to be the expected output to be where the 10 is in this example, in the if. And then you can change the third item to be the point value, right? So you change points instead of by 1 by some variable amount. But this is just like a small example. So this is how a test would look like under the hood. Could you go to the next slide, please? Yeah, so how do you actually call the functions? Well, you can actually put everything together. You can make a global variable that stores the result of your autograding. In this case, this test only records the point, but you can make it a JSON, which we have done for our Grayscope integration. But for this example, it just outputs a 1 if it passes, and a 0 if it doesn't for the points. So if you bind it like this, when you broadcast the message autograde, it will set the global variable to the execution of the test, right? So yeah, next. So you might have noticed there are some gaps in what I've explained and what was the norm for manual grading, which is how do you upload a project into Snap, and how do you actually write code in a scripting language that runs these blocks? Well, Snap has an API in JavaScript. It allows you to basically fill in these gaps. So you can upload a project given its XML. So you store that as a string variable, and then you can call the function using that XML string. That'll upload a project into Snap. You can broadcast a custom message like autograde, and you can get the value of a global variable. So you can, as you can imagine, with all of these elements and what I've just explained, you can make yourself an autograder in JavaScript. And I highly recommend you check out the code on GitHub, in particular the file api.js. And I have a quick demo, but I think I have to share that. But although if you click on it, I think I have instructions for that. So Victoria, if you could follow that, that'd be great. So you can hide that. Yeah.
Sorry, I think I'm lagging.
Yeah. So is it possible for you to open up the, so this is the same thing that I've shown in the slides, test double and everything is similar. Could you open up the JavaScript console on your, on this? I'm gonna try, I can see if I can try to share. Give me a second. I have to set my
Wait,
permissions.
did you want the JavaScript file?
No. So on the website, you can open up a JavaScript console. Yeah, on the website itself. I'm not sure how to do it in Windows. I know it like inspect element. Let me try to have to give permission for my computer to share screen. Give me a sec.
Try pressing F12.
Okay. Give me a sec. All right. Okay, can you see my screen?
Yep.
Okay. I hope you can see the developer console when I open it. Can you see this console here?
Yep. Yep.
Okay. So I have a project. So to grade it normally, you would have to open Snap and click on these blocks to autograde or like broadcast a message within Snap, right? This is not what we want because we want to run Snap headless without any browser at all. So in order to do this, I've set up the Snap file in such a way that if you receive this message, autograding will begin, right? So so from JavaScript, you can actually do that. So you can upload a project in using JavaScript. I won't touch on that right now, but in order to broadcast a message autograde, you can run this code, and this is from the api.js GitHub file. So when you run this, notice global variable will change to 1 because the points has to increase because double is implemented correctly. So I'm going to run this. And as you see, the global variable has increased to 1. And let's say you didn't have this visual, right? And you're in JavaScript. How do you get that grading value or that value that is stored in global variable result? You can run this code in JavaScript and it will give you the value of 1, right? If I reset it and I run it again, it'll give me 0, right? Because that's the default value of the variable. So as you can imagine with this in JavaScript, all you need now is some sort of web driver that can run JavaScript code on a browser, which is how our autograder works right now. We use, initially we used Python with a library called Selenium, but now we switched to JavaScript with a library called Puppeteer. So we're only using that to run these API calls for Snap. And we can upload a project, we can start an autograder to run, and then we can get the result. In this case, it's just a number, but you can get a JSON as well. You can save that to a file and then upload that to Grayscale. Yeah, so that's how this autograder thing works under the hood. Okay, that's it for me. Yeah, if you have any questions, we'll be here at the end. Okay, Victoria, can you take it away?
Yeah, let me get back. Sorry. Oh, where's the presentation? Okay, yeah, so I'm just gonna show like a high overview of like what we just talked about and the process. Presentation. So sorry, oh, my computer is so slow right now. Let's see. Okay, so here is a breakdown.
Perfect.
Here's a breakdown of the process. So just as Lam talked about, we find the blocks, we make sure that exists. So we're getting the block by the label, we're extracting it, we're saving those blocks to like a student variable, which is a global variable, and we'll call them later. Once we do that and they're there and we're good to go, we then like configure the autograder by like setting all the tests we want to test for, creating weights for them, any additional constraints we might have, like is this block recursive, things like that we might add there. The next process would be then actually running the tests themselves. So that it will run every test. Basically inside of each test, what happens is we have a bunch of a bunch of inputs and a bunch of expected solutions, and we take the student code, we plug it in, we call it, and we see if that matches the expected output. And if one of the tests fails or it errors, then it'll report false, and it'll have a message in a string like what's wrong. So it'll report the why it failed, the expected output, the actual output from the student, the data type, expected data type, actual data type, just to give the student a better, clearer view of what's happening and help them debug a little bit better. So all of those tests are saved to the results global variable, all in a JSON format. So all the data, including the name of the test, the weight of the test, how much it's worth, the error messages, all of that is all stored in results and exported into our grade scope. Now we have some demos. So here is an example of a local autograder. So this is a starter code for one of the labs that we're doing. So here I have this local autograder, and these are the blocks that the students are supposed to fill out right here to my left. And this local autograder basically gives me, I mean, if they were correct, it would all say test passed. But here I have my error messages, my test failed, here's my input, this is the expected output is true, and I actually got a number, and I can scroll and see, oh, the data type error. It was expecting a list, but getting an error. Oops. So this is super helpful for students to be able to debug their code. It's transparent. They know exactly what's going wrong, and they can keep working on it. Here is what it looks like in Gradescope. So it's the exact same thing. It's just, this is the Gradescope version. Here we have our scores, runs all of it, and same error messages, all of that. And we also have some hidden tests. The hidden tests don't reveal the inputs and expected outputs and all of that, because we don't want the students to hard code the problem. So that's why we have these hidden tests in there. Next, I want to show a fractal. So we've been autograding fractals. Here is a student submission of a fractal. It's not correct, it's wrong. This is what the fractal is actually supposed to look like. Let's see, I loaded the autograder here. What is it? It was 51. Oops, let's change that. Oops, no. Label 51. There we go. Okay. So here's what the fractal is supposed to look like. Obviously, the student's submission is wrong, but we don't want to, say that everything is wrong. They may have some aspects of their code that are correct. So we now, are, especially with the meta programming, with the 8.0 version, it makes it very easy to do all of this. So we can now look under the hood. We can check their base cases. Their base cases are right? So we want to give them some partial credit. So that's what these kinds of autograders are doing here. So the lab autograder was kind of like a all credit, zero, you have to get everything right in order to get credit for the lab. This is something where we're delving into individual little facets, and we have specific tests. We have a base case condition, a drawing, number of recursive inputs, was all of that correct? So we're able to do that pretty easily and just check using some, like autograder utilities. We can basically do pixel comparisons between the expected solution and the student submission. We can play around with the levels, like the nested levels, like levels 1, 2, 3, like each recursive call. So we can take a look and substitute those and see if those inputs were correct. We can see if the length is correct, and just give, the right credit that they should get for their fractal. Another example of the autograder that we want to showcase is this more general version. So this is something that we would like, teachers to be able to use. This is like a proposed version that we have here that we want to release, and we want to, enable JavaScript. Okay, so yeah, here is a version that we want to release to everyone. We want teachers to be able, and instructors to be able to take advantage of this and run student code. So currently what I can do is I can export this, this sprite and then upload it into a student submission and auto grade it. I can also, use the JavaScript files and some shell files and configure it to grade scope. Obviously, everyone's not going to have a grade scope instance and be able to access that. So what our proposed idea is for future versions is to basically make some kind of like library, something like that, where you don't need to have any JavaScript, any external files or anything like that. You can just be able, what we want to do is have something where you can have a bunch of submissions, a bunch of student submissions, and just grade them inside of Snap, making it super easy, not needing anything else except Snap and the files that you have as an instructor. Okay, I know I'm running out of time, so I want to make that quick. So yeah, thank you. Time for Vedansh.
Lovely. Okay, thank you. Let me, let me try to share my screen. Okay, so implications for BJC. So brief background. I am currently an instructor for BJC over the summer. In regular semesters, I tend to be head TA with Dan, which means Dan's job is to have visions and have really great ideas. And then my job happens to be to take ownership of the nuts and bolts of the class, keep my finger on the pulse of the class, and make sure things don't blow up. So I'm going to talk about the implications of auto graders and this policy of no lateness penalties in BJC. So how that's played out, the lessons we've learned, and how we might adapt it for future versions. So we'll start with auto grading, the joys of auto grading. Quite clearly, we've saved a bunch of time. So from the staff point of view, we now spend roughly half the time grading that we used to before. Well, why we're spending half the time is because we still have some essay projects. We still have some reading quizzes where people actually write things that human beings should read. But that clears up 70 hours in our schedule that we can now dedicate to student support. So what does that look like? Well, now we have discussion sections, which are these recitation sections that run at twice the time, right? So we have 2-hour discussion sections instead of 1-hour sections for students who may have fallen behind. We have dedicated student support office hours, 2 hours a week where students can just show up and say, hey, I'm behind. Can a TA help me make a plan to catch up? And we're there for them. We're able to look at our submission logs, reach out to students who've fallen behind and help them come up with a plan to catch up. All of this would not have been possible if we were still using our 70 hours grading. So it opens up some room in our course to be able to actually support students when they're sort of lagging behind. Then we have time from the student point of view. Because students get instant feedback, because the feedback loop is so optimized, it usually leads to quicker completion of projects when the messaging is right, and we'll get to that later. So what we noticed was that between the summer of 22 and the summer of 23, when we implemented the first project in a functional manner and added the autograder, students tended to complete project 1 roughly 54% faster than before. That's 106 fewer hours between release time and submission time on average. Of course, that doesn't mean students are spending 100 hours less of coding, but it does mean that for those 4 days, they don't have to worry about the project anymore. They've turned it in, it's off their plate. And in a class where you have projects back to back to back, that opens up room for them to catch up on other material that they may have fallen behind on, which we've gotten some really good feedback about. Now, there's also some challenges. There's time that goes into developing the autograder. So I think the bulk of the time goes into rewriting your assignments to be functional. That means updating your specs, updating your functions, creating new code, which Dan did for us. It means writing an autograder and porting it to your external grading tool, making sure that it's compatible. It means collecting a bunch of submissions from staff or previous student submissions and running them on the autograder to make sure it works. So that testing takes a little bit of time. There's also time that goes into deployment. Initially, when you launch new autograders, you get a bunch of feedback from students and you're making revisions on the fly. So you have dedicated hours to make sure that the autograder is being patched whenever it's necessary. But we noticed that when it comes to maintenance, our maintenance cost is practically zero, because once you have an autograder ready for an assignment and the assignment doesn't change, you don't really need to revise it. And when it comes time to move on to the next semester, the framework ports readily across semesters. There's barely any changes needed at all. So it looks like you have this one-time cost for setting up the autograder, but it pales in comparison to the cumulative savings that you get in both staff and student hours semester after semester. So from a time point of view, we're doing okay. Now let's get to learning. Well, under this keep working till you get it right model, we believe the students are actually doing the learning and doing better, and the numbers support that argument. In summer of 22, the average score on project one for students was roughly 87%. This summer, not a single student got less than 100% on project one. And a few reasons for that is, well, A, when we didn't have an autograder, students get one submission that gets graded, right? So they don't really have feedback on previous versions. Now they might submit, they might see a 60, but they keep going till they get 100. So that live feedback loop really, really helps. Secondly, when you rewrite the projects to be functional, debugging gets a lot easier because the student knows precisely where the error is, what the error is, and what they need to do to fix it. So that makes their lives a bit easier. And of course, we have more student support opportunities. If you're not burning hours grading, you have more hours to actually help students with the project. So that's worked out pretty well. But there's also a caveat, which is that if you have an autograder out there, students might get more reliant on the autograder, right? If a measure becomes a target, then it might become a bad measure because students might start spamming the autograder, just trying to make it work. And in the end, they don't quite know how their code works or why it works. They just know that it works. Now, to kind of circumvent that, we also introduced something where the autograder grades student written tests. So we're making sure that the student actually understands what their code does. It's not a perfect solution because we can't readily grade for the quality of those tests, but it seems to help to some degree. And there's also the issue of more subjective feedback. So for instance, if you want to grade students on style, the autograder as of now can't really do that. That would have to be a human being going through your code and telling you, hey, you should have used a descriptive variable name, or maybe a nested for loop wasn't the best idea, or so on. So that's something that we can work on. Then we move on to the second part, which is no lateness penalties. So back in fall of 2022, on day one, we announced in lecture, no lateness penalties, yes, really. And this seemed like a really good idea, and it was. Students now had more flexibility to move things around in their schedule whenever they get time. Staff does not need to burn hours processing extensions because there's no lateness penalties. You might submit whenever you need, fill out a form, and you're good to go. And the students were delighted. So some of the feedback we got was, as long as I worked hard, I'd be able to get a good grade. I could arrange my work in life more flexibly. The semester is short, classes are all intense. I love this policy. So students were really happy. But this second point actually ended up being somewhat of a problem. Classes are intense. And now if you have one class that tells you submit whenever you want, that class becomes your last priority. So we noticed that in fall of 22, our average project completion rate in our last checkpoint for project submissions fell down to 57%. We usually see numbers around 90, so that wasn't really nice. And we noticed a snowball effect. If you fall behind on project one, you're now falling behind on 2 even more, and 3 even more, and so on. So that was kind of a problem. But we fixed it, or tried to fix it, in spring 23 by introducing this new layer of friction, which said if you need a longer extension, you need to get approval. You need to talk to a staff member. We would never say no, but they didn't know that. This added friction was very, very helpful. And as you can see in the figure below, our submission rates, popped up far higher than they were in fall 22 by adding this layer of friction. But we keep iterating and we're improving more and more. And in summer of 23, we've tried this new method where we've told students, you won't get extensions beyond 72 hours and you will have late penalties. But in practice, we don't actually apply any late penalties. And when we reach a point in our course where we know that they're going to get some room in their schedule, when we know that labs aren't packed back to back, we reopen the assignments and allow students to resubmit without lateness penalties. So when things are hard, you push because you need students to be in the process, keep doing the work. But when you see that, in terms of CS10, there's some room opening up, you release your grip and you allow students to turn work in. This has worked really well for us now. It's not a perfect approach, but from what we're seeing, we've had 2 projects already. On project 1, we had 100% students submitting. On project 2, all but 1 student turned in their work. So it seems to be working pretty well. A few more things we're trying out is...
I'm sorry, Vedansh, we're actually getting the boot right now to wrap it up.
Oh, sure. Yeah, so I think that's all I have. We're autograding labs and supporting students who work at the end of term. That's all.
Beautiful. Yes. So I just want to please feel free everyone else to chime in, but I just want to finish with, we really, it's been great to do this for CS10, and it makes life so much easier, but we also have staff that was able to grade. So what Lam and I really want to do is we want to make this available for high school teachers and middle school teachers who do not have extra staff members to grade tons of submissions. So yeah, please contact us if you have any questions. We're going to release this, so hopefully you're able to utilize it. But if you're realizing something doesn't work great, we'd love for you to contact us and we can try to fix something. We also want to have future releases, and we'll try to make like announcement in the forum and whatnot. Yeah, so here are emails. Please feel free to contact us. And that's it for me. If anyone else wants to say anything.
And thank you for coming to our talk.